In this video, we are continuing the last video on purification and analysis of that purification process of proteins. Now, when you're purifying proteins, one way you can measure the amount of protein you have is through absorbance. And that's because if we look at this plot here, both tryptophan and tyrosine absorb light at 280 nanometers. Phenylalanine also absorbs light at 260, but DNA absorbs light at 260 as well, so we don't use that wavelength. We use 280 to measure protein concentration. To measure protein concentration through absorbance of light, we use Beer-Lambert's law. Beer-Lambert's law is A equals epsilon CL. A is absorbance, epsilon is extinction coefficient. An extinction coefficient is a constant that is calculated for every protein or amino acid or anything that absorbs in light. C is our concentration. L is our path length. L will usually be 1 for every type of calculation you do in Beer-Lambert's law. So if you know E, which you probably do, you know I, then you can relate absorbance to concentration. Now, if your protein contains a chromophore, like GFP does, you can measure absorption of light in that region as well. Now, when you want to purify protein from a crude extract, you usually do it in a stepwise process. We call it a fractionation process. You're fractionating your crude extract, basically. And you're using physicochemical properties of your protein to separate it, such as your protein's solubility, its overall charge, its overall polarity, its size, or its binding specificity. These are physicochemical properties. And note, when you're purifying a protein, you will lose some of your protein, and that's accepted. There's nothing you can really do about it. The big thing is, you're losing more of the other stuff, the junk, the stuff that's not your protein, and that's the goal here. How to minimize the loss of your own protein while maximizing the loss of the proteins you don't want. And honestly, this is an art. And by that I mean it takes a lot of trial and error. If you're working with a protein the first time, you'll probably spend months just figuring out how to purify the protein. Before you do any science on this protein, you need to learn how do I purify it from either E. coli or from a tissue or what have you. So the first method we're going to see to purify a protein targets a protein solubility, and it's called salting out. Now, solubility of any given protein depends on a lot of things. It depends on the concentrations of salt, the polarity of the solvent, the pH of the solvent, and temperature of the solvent. Now, salting in is an interesting phenomenon. We see that at low ionic concentrations, that is low concentrations of salt, solubility of a protein actually increases the more salt we add. While salting out is kind of the opposite. If you're already at high salt concentrations, proteins will actually aggregate and come out of solution. That's what that's supposed to say, come out of solution the more salt you add. We're not going to go into the physical chemistry reasons for this. But what you do in a experimental setup, if you have, for example, your target protein is green and you're trying to separate it from all the other proteins, you will add a salt, usually NH4, SO4, just before your green protein would salt out or precipitate. So let's say your red protein here has a lower solubility than your green protein, so you add enough salt just before your green would come out of solution. And here, after this happens, you would remove the supernatant or That is, you would remove all the liquid portion and put that into a new test tube, and so your red would be separated out. Then you add salt, so your green will come out of solution, that is your protein that you want, while the yellow protein remains in solution. You remove the supernatant again, this time keeping the precipitate, and now you have successfully removed your protein from other proteins. Usually you can't just purify your protein through salting out. There are many other things you have to do, and we'll talk about those other things in the next video.